It is my pleasure to welcome Daniel and Ben from LTX. I was talking about them this morning. They make many different pieces of software, but my reason for bringing them here is they are making the premier open source, open weight video model, and it is a really important piece of our vision for render. I mean, we definitely need open models to be able to add and fine-tune features, to run it on nodes on the render network. And they're also developing really unique features that I don't see in other models as well. And I think this space is, the more things we can piece together for the ultimate workflow and tools is an improvement on where we are. And I feel like the work being done here is great. So it's my pleasure to welcome Ben and Daniel to the stage from LTX. Thank you, guys. Hey, you made it. So good to have you here.
Hey.
Welcome to RenderCon.
Yeah, thank you.
Thank you, guys. So I figured we should start with a bit of background on Lightricks and what you guys do. I know there's a lot of time, there's things beyond, of course, generative AI stuff, but it is your history, how you approach the things you're doing, why open source, and what your vision is for that. I think that's a great place for us to begin.
Yeah, absolutely. Yeah. Thank you for having me here.
Pleasure to have you guys here.
It's great being here. So really quickly about Lightricks. I don't know how many of you know the company, but we started a very long time ago from a completely different angle of the business, from mobile apps for photo and video editing. So we were always in the business of building tools for creatives. That was something that we were always doing, but in a very different domain. And about 3 years ago, essentially, when this huge revolution has started, we realized that we were talking about it actually earlier today, that we prospered really where we are at the cutting edge of technology. And we realized that now it's in a different place. So we kind of changed the way we're working, and we basically moved to create AI-based tools for video production, all the way to create our own foundational model, which is LTX. Yeah, and you said a video model, so LTX is actually multi-model model. And like you were saying, it's open source, open weights. The way we're thinking about it, from our philosophy, is that when it comes to creativity, I think that it's very easy to see it from even when we look at interfaces of the traditional tools that we're using, right? I mean, people in here the interface of Maya, of Blender, of After Effects. We're talking about really massive, complex interfaces, which I think tell the story of that for creative process, you really need freedom and flexibility in the way you're working. Right? You can't choose a single tool to do something. You have to have the freedom and to really express what you're trying to do creatively. So we're thinking about being open source, creating an open toolbox for creative professionals.
Well, yeah, and I mean, frankly, with an open weights model, I mean, the reason, this panel, by the way, is to talk about world models, and the reason why world models are relevant to what you guys are doing is the only ones that, other than Google's Genie, right, and Tencent ones, WAN, which was done by Alibaba, was, before you guys came along, it was kind of the go-to open weight video model, and they stopped putting out video models after WAN 2.2, like they're on WAN 2.7, it's closed. And the thing that was powerful with their releases, and it's true of what you guys are doing now too, is that people would just take that and speed it up and fine tune it. And so you have, on Hugging Face and stuff, I mean, you have world models, things that are built off of those things, and that's what people are working on that with your guys' model as well. So I look at the importance of world models and having those actually be things that we can run on any machine, work on those. I mean, collaboratively build on that stuff is being foundational, and you guys are really the only player, I think, at this point that's delivering that. And I will say also in your model, I mean, I test all these things out heavily. I mean, I just spend a lot of time on these things. You do 4K, which is unique. I've not seen that in other video models, closed or open. And also I guess you're running at 50 on LTX too, high frame rate. And there is, and it is also, I think the people that are trying to build, and fine tune it's such an important piece of it. I mean, so many things were built on WAN, they've moved to LTX. And I think you guys also have ambitions for doing really great work, independently of the fact that you guys are open weight. So all those things are really fascinating. And, there's not much, I mean, Ahmad, who's speaking later, I mean, he's founded Stability, and that was a huge explosion. I don't think that we would be in this place we were today if we didn't have the stuff that stability sort of fostered by being this open model. Obviously, there's a lot of things that have happened since the heydays, but with video and especially, I was talking to you guys like 6 months back about 3D. So I was mentioning even to the, on the last panel, if you have enough references, you're starting to be able to feed in a 3D scene, yet it's in latent space, so you can dynamically control it and change it without having to worry about vertex deformations. Also, some really interesting things. And then we were in a whole different space. And if you guys can tell me, I'm so excited for that to be more steerable. And I feel like you guys are definitely committed to that. And it might also help that it's something that can run locally, where you can blend that with your 3D tools and many other things. So yeah, I'd love to hear your guys' thoughts on your roadmap or anything else that you want to share about where you're going. I just posted a video this morning where it was, I think, from David Ariu, Octane Jesus, in the audience, who was showing that you can just take a Garud shaded viewport and just run it LTX over it, and it gives you back a final render. And this is the fulfillment of basically having the rendering equation not be handled with the ray tracing, but just be handled by model. It's still 3D. It's still every surface is being defined by the 3D simulation, but it just shows the spectrum of where these things go. And also the fact that you can run it locally means it can be embedded in local tools.
Yeah, absolutely. And also, you mentioned Emma. I think I'm waiting to hear him later today. But I think that that's actually, if we go like a history of like what I was saying before, this is actually what kind of like got us into training our own foundational model. Because in the beginning, we were kind of like most of the things we were doing, we were kind of like counting on stability back then, as the like leading the open source models. And at some point, like with SVD and whatever was happening, like with stability, we realized that this is like something that might be in risk, and we figure out like, okay, that's where we come into the picture, and like that's something that we can do. Um, and I think that like what we've been doing since then is really trying to understand, like, and I'm coming from product, so my goal is like not to be in charge of the tech itself, but to kind of understand what people need when
Yep.
they actually use the model, right? Like what type of capabilities are going to be very relevant for what they're doing. And what we're focusing on right now is really being relevant for creative professional, final pixel, and getting to production level. I think like Ben here is like probably like one of the best people to talk about it, because like we were partnering with Asteria and what the work they are doing, and they're kind of like the people that we have in mind when we're building the next type of capabilities and tools. Um, yeah, and like one thing, like you mentioned, like the fine tuning, which I think is such a great deal of what you're doing. Like so, fine tuning, I think it's a vast thing, vast term to talk about. The way like LTX built is that it was built. The architecture is built for efficiency, but efficiency means not just efficiency in terms of like the training, but also in terms of like the inference, and
Yep.
in terms of like the real-time rendering. There's like an external team to LTX actually to just show that you can do like 1080 4K real-time. So this is very initial, but these are the kind of things that are happening when
This
you
is
have
like highly quantized version of it. Yeah.
yeah, when you have like an open model. What's like the amazing thing that you see is that the participation of the community in what you're doing is just really becoming amazing, right? Like we basically went like with a recent model like open source about a quarter ago, so really not a long time.
Yeah.
Not a long time that it's been out there, and we're already seeing like amazing things happening from the community and from research team across the world, basically.
Yeah, I mean, and track it carefully. I mean, it's somebody that's obviously we want to provide all these tools to artists. We want to think about render network as well, because cost and all these things are factors. But the thing that really intrigued me was, again, sort of your guys' openness to these models, where it's like, okay, we're not just necessarily feeding video. The idea of input and outputs being 3D space, other things is really, I think you have to think outside the box a little bit. Um, and I'm not even sure really what like splats, for example, are a really interesting output format. I think you guys were one of the first companies I talked to that were like, we're open to at least ingesting and spitting that out. And short of that, like we built a little tool that like we'll go in there and try to reconstruct that. We have that on render so that if the model doesn't have it, we can still try to do that. As you heard from Darren, it's like, well, if you have those kinds of tools, if you're effectively whatever you're doing, if you're generating or rendering, I mean, even as a render, right? If you're rendering into a splat and you have this thing and you want to edit it or change it without fully doing the re-render or having all that data, it is possible. And it also just feels like a lot of the issues that generative gets wrong. It's like it would help if you had a compressed spatial idea of this thing that you can define and set in there, not just from pictures or images, but from some sort of like, more rectified data structure. And spots are a good example of that because they don't need to be triangle soup, and it could work. So, have you guys have anything on the roadmap specifically for that, or any thoughts on that? You know, sort of that intersection with 3D as you guys progress with improving the video model.
Yeah, absolutely. So again, like one of the mechanism that we see is like really useful for a flexible type of output is really like training IC LoRa's. Essentially, when you have like pairs of videos like that you can train on, and like LTX is really easy to train over,
Yeah.
you can basically build like all kind of like different custom controls that are relevant for whatever pipeline or workflow you're trying to do. So that, and into that you can put in, so like the regular thing that maybe people here know about, like controlling like canny and like depth and all of
Yeah.
these type of different controls. But the same way we do it like with a 2D type of input, you can also do it like with a 3D type of input. So with
Yeah.
splats or like the actual like 3D information directly from any like from your favorite like 3D software.
Yeah, and of course, every 3D software at least gives you a depth map and normals and things like that. And it's surprising because I have seen, and I was talking to the Kling folks earlier, right? I mean, it's like you have references, and the references give you 16 megapixels roughly, and you can fit anything in there, including all the. I mean, I can basically do a turntable inside of that, and that is getting us really close to what I would expect from a splat. Like, in fact, it's even better because I suppose I can get really close to certain details. The model has that, and being able to group things like that, or as I said, I mean, it makes you feel like you're at least dealing with a structure, and when it gets it right, it's great. And I think if we can get to the point where it's as solid as a 3D model, I mean, holy crap, that would be huge. But also the fact that you guys are pushing resolution, frame rate, um, really, really good stuff. And also, I think the open source community is powerful. I mean, stability and all those things these building blocks are done on top of WAN. I mean, they were really unique. I haven't seen those necessarily in closed models, and I think you guys are poised to get the benefits of that. I've noticed the community really gravitate around what you guys are doing as the only, serious open source, model that people can work with and build on. And I think there's a lot of things that can and should be built. So
I would also say that, one of the things that we're, I think excited to partner with you guys lately on is the color depth as well, which I think has been a huge frontier. So we're cousins, I guess, in that we are in a studio that partners with LTX to sort of, and we're focused more on like high-end film production.
yeah,
And, that's the first thing that people, that was the first kind of, barrier, I think, was color depth. Resolution, there were upscaling methodologies, you could tile things in and composite them, but how do you actually manipulate the final output to be able to, sit with other elements, whether it was live action or CG elements. And so I think it's remarkable that LTX, is not just developed that technology, but open sourcing it for
yeah,
people, because I think you can see how that can now plug into, and I think that's kind of the beauty of the open source model anyways. Like our company is sort of was a nomadic tribe of open source, kind of circuit vendors of AI. And we're always looking for the types of partners that sort of were thinking about these things where you were getting, those kind of niche, if everyone else was focusing on generalization and sort of a really pretty first pass, it's like, what does it take when you're working with, like a James Cameron, and all of a sudden you have to do pixel level,
I'd hope if it's David Fincher, every
yeah,
pixel within counts.
yeah, the pixel fuckery, how
Yep.
do you,
You know the term?
yeah,
I've worked in
how do you exist in that world in AI? And so I think that the only way to do that is to enable lots of controls. And so I think that's kind of like, and the fine tuning as well, which I think even when we talk about using image references, it gives you a good idea of what something is, but it doesn't necessarily understand the context of how foliage moves in your world, or how wind or environment, or even when we deal with characters, like how the specific nuances of their performance. And so even though models can generalize really well off of limited reference, the ability to give users the ability to fine tune models themselves, which is something that we partner with model companies, but most consumers don't have access to that, right? To be able to actually, move away from generalization and have a model that has a very specific, scalpel-like quality.
And even though I didn't really spend much time today talking about our face work, we've been doing, visual effects services for the industry. I mean, one of the things we've done for Picture is we scanned a Benjamin Button on light stage. We have all these data sets, and we built a model for mapping your faces in real time, preserving the actor's performance and nuances. That's what we used with Sam Witwer when he portrayed Captain Kirk in our short in 24. And it is just for faces. I mean, it's very specific. But if we paired that and we were looking at doing it with that, and now we have you guys, it would be really interesting to sort of bring that into a unified model. And that's the kind of stuff that is impossible to do. And there's this barrier between closed and open. So, but you're right about the scalpel thing. I think there's a lot of value in addressing these specific pieces and seeing how you can build a more cohesive pipeline around it. I will say that did you guys? I don't think you guys were here this morning, so I don't know if you saw the presentation I was giving earlier. But to me, all these issues are like if you basically if everything is effectively always being turned into 3D or is 3D to begin with, then in some ways mistakes can be corrected, references can be rebuilt, and I kind of think that even that little Star Wars clip we were just talking about, I was like, well, this is separate from the generation part. Editing these pieces later, even with generative elements, but with all of this data starting with a 3D scene where you can turn it around, you don't have to do whole filling. It effectively remembers all of that and constructs it. It is pretty powerful and relightable, and it can go into 3D engines. So we're seeing how that works. I think it's pretty new stuff, but even there, it feels like we're going into a world where everything, even in traditional CG rendering, is going to have that neural pass. And while DLSS 5 was not really well received, it just feels like you might bring your own neural renderer of choice, and that's just on the shading level, but also in the scene graph, so much more can happen. And I think to your point, I mean, if you're trying to deal with foliage and all these other things, we have plugins in the 3D pipeline for doing simulations and things like that. But if you have different models that are specialized that can interact, you're going to end up with something even more powerful, interesting, especially if they can be trained locally and added together in these interesting ways.
Yeah, absolutely. I think that we also see, if you look over the last 2 years and what's happening with models, and we see, there are many great models out there. We saw some really great stuff from Kling just a second ago. There are things like there are really shiny pixels. It's getting better and better, more and more impressive. But I think that what we're trying to focus on is kind of steering away from actually the world of automations and the world of kind of slot machine experience, and kind of going to really giving you the creative control that you need. Because like Ben was saying, when you come to create something, eventually there's a creator at the other side, and they have their vision, and they want to get to what they have in mind. And I think bridging that gap between what they're actually imagining and what they're getting, without the feel like you need to make compromises because now you're using the tech that is different.
Yep.
I think this is for me, it's the biggest thing with AI. And I think that you were also referring to it earlier, right? When you're making a movie, it's about the story. You're telling a story. You're telling it in a really beautiful way, and it's not about the tech. The tech isn't the story. And I think that for that reason, we want to get to a point where creators, when they make things, they don't actually stop and to think about the technology. For that, the technology needs to serve whatever they're trying to achieve, right? I think that the same type of control and authority that traditional tools give creators are now kind of people are talking about should we now compromise because there's a much more efficient, a much more cheaper way of doing things, much more faster way of doing things. What we're trying to get to is okay, we want to give them the same type of power and control they had and confidence they had before, but doing it in a completely different way. And I think for that, you have to be much more flexible and open in the way you're working. So right, if you're trying to create something very specific, suddenly you can't just hope for the model to spit out something that looks good enough or shiny enough. Maybe you need to reconstruct the whole set in 3D and feed that into the model to really keep it true to what you're trying to do, right? So I think this is kind of where we are now.
I think in many ways too is we're still in such early days where in the first iteration of AI there was one keyframe, which I think for especially coming from the background you have and having seen the staggering amount of keyframes that it generally takes to produce a single shot, and for different a bevy of different sort of parameters, and
10 keyframes.
Even 10. And I think what to their credit, being able to multi-keyframing, which is a big part of the approach, the way that we work, right? We're how much can you close the delta between a moment in the assessment or appraisal of a shot? Do you need to make a new decision? And being able to pull a keyframe out, manipulate it, and rerun it. So so that you're each process of generating something isn't, a sort of a spread of, kind of disparate,
Yeah.
slightly similar outputs, but like one very intentional thing that you drill down and do multiple iterations on. If you look at, any CG asset file is usually like V17, V18, V19, V25, final, actually final dot, MA, that many levels of iterations. I think trying to find something that, emulates that that capability, and that, I think that's why having the ability to keyframe on a LTX is like a huge.
It's huge.
Yeah.
I mean, 10 keyframes, even and I think that we're it is sort of like things are changing a lot. Like there was only, I mean, there's really just first and last frame, and not all the models have that. Like I think Clean 2.1 didn't have last frames. VO 3.1 didn't even have the higher end model in that first last frames. And what we really needed is, like as I was saying, like you need references in the middle of those keyframes, and ideally you want keyframes in the middle of those keyframes. So one thing that is like to be tested are the Omni models. Kind of like, do they work with this stuff? But then again, can you? What I've noticed is the Omni models don't necessarily lock the first or last frame in, even if you specify that. So you're losing. Again, if you can get the kind of control and you can have all the data going in, it's like it is becoming. You really will solve almost all the problems that I think currently are frictionful. I think it's great that you guys are working on extra keyframes. That's a really welcome.
And keyframes with conditioning, so depth or any, canny, pose, any of those things. So having, an image of conditioning, in addition to keyframes that give you aesthetic landmarks along the way, and not just first, middle, last, first, middle, like 5 keyframes. Being able to be frame specific, especially when you get into like complex camera moves and you're getting into, now you're orbiting around the back of something where you don't want the AI to hallucinate or imagine what it's, behind it. Those are things where, but you want to preserve that motion. Those are things that I think get into a methodology that speaks to how artists like to work.
Oh yeah, for sure. And it's so interesting because the truth is you're there if you have like a couple of video inputs. If you to basically create, I don't know, again, I was showing this thing. It wasn't even a CG scene. It was just filmed on green screen with a couple of markers. But the camera tracking is in there. So the camera tracking is in there. Your camera is set. You can, if you want to have a very specific thing, just go into any 3D tool and just spit out a USDZ file with a camera path, and and if you have a video input of that fed in, and then you're adding stuff on top of it, well, your camera is built in there, so you have that control. And I think that if ultimately the more of those kinds of pieces, that's why multiple video inputs are really useful. You shouldn't have to guess the camera control. You should be able to control it no differently than CG. And if you have a video-to-video model, or at least the underlying camera is controlled by the video input, regardless of what it is, even if it's just a bunch of markers, you're good, and I think that's really where more of that stuff will get it to be a lot closer to the CG pipeline, production pipeline we're all using, and it feels like those are definitely like they're coming together pretty much in the current state-of-the-art models, and you guys are on top of that, and more data is going to make that work even better for more elements in the scene, for sure.
Yeah, absolutely. I think, Ben, what you were talking about is kind of like the very like natural nature of it, which is like an iterative process, right? You want to create a process that you feel like you're making progress, and something that converge, like a creative process that is converging eventually, and not something that like you kind of like start from scratch whenever you do something. The second thing, I think, is something that is also like predictable and repeatable.
Yeah.
I think that, like that's really important. Like when we talk to like different like studios or media companies, like when they think about like a production, they think, okay, we need to have some kind of estimation of what's it gonna cost, how it's gonna work, how we're gonna like actually utilize it in our process. And I think for that you have to have like a setup that you know how it works and you can like kind of predict what's gonna happen.
And we have that for the things that are not really filmed. That's called CGI, and typically we're just, the only reason why I think AI is disconnected from the thought of CGI is that the tools that CG artists have typically used have been absent, and starting with control. But I mean, really, almost. I mean, I'm in the business of rendering. You end up shading a surface with a material definition, and I just feel like you can definitely do that with neural models. Like you just feed in. I mean, that's the whole point, right? And the depth map and normals. I mean, it's almost like once you have that locked, then you can change the lighting. But also, if you can move things around, I mean, it just starts to go back to that. And I think the models. I'm seeing this emergent behavior in almost all the top models where I can start to treat elements as objects. I just need more of that, and I need to make sure it never fails once it figures out how to get it right. But the fact that it can do it at all is pretty interesting. And the camera input, the video input, I was waiting for that for so long. I was like, there's no point in me spending time on these models until I can at least control the underlying camera track. at least for me. And I think that's that. Plus, you have the same thing for elements. Like here's a bounding box wireframe. I mean, you're starting to get much closer to the traditional scene graph that we've all built our production careers on top of. So.
I would say lighting is equally important, and we're working on a feature project right now, and really in the early stages of development in that, and that's the production designer and the director are really, for them that's really important. Like obviously you can take an image and then open it and say like give it 3/4 backlighting, and it'll give you that, but that's not how they work, and they can maybe paint over that image and give you a lighting key that gets you closer, but a lot of what we end up doing is actually taking it into a 3D package, and I think that you're going to see like stacking renderers. Like we use Octane a lot as like a,
Thank you,
just to, well, it's a beautiful renderer and it's fast, and you can see how stacking Octane with where you want to have someone that's like, I want to dial up the intensity of the key light by a set value. I want to bring around up the fill like and actually build scene lighting, but maybe on a static environment, and then all of a sudden you're using a generative video model to make sure that so you don't have to go render physics on all the trees and on the water and all that stuff. Like
exactly where it's going.
Yeah, but you want to be able to have that granularity control. So I think you're going to continue to see, and I think what's going to be really exciting is when you start to see the models enter the DCCs themselves. Right now we're kind of like bouncing between Comfy and some web UI and then back into your 3D package, but like having those things exist harmoniously, and where you're even stacking renderers, I think is like going to be something that you're going to see.
100%. And, so we had Francesco, from Blender here, and we were talking about, I mean, on the Blender side, the scene graph, the MCP stuff that just controlling what it does is useful, but you're right about multiple renders. I mean, it's like you have compositing passes now, and if you want to use high-render delegates, you can have 3 different renders, all render different parts of the scene. And we even had thought about putting that in Octane in the compositor. Why not? If you have, if you can load those delegates in there, but with AI or machine learning or anything late in space, I do feel like, well, this is something that's like, well, we got Gaussian splats to, I mean, V-rated it first, but they didn't do reflections or shadows like we did, but we have it in there. So it's like, it's now, whatever the splat is, it is just another primitive type. I think that when you have latent space stuff that's like that, that's going to be a really big deal, because then you're effectively rendering into that space and keeping whatever you need to have as like a rag or something that is the structure that needs to be there. But also the effects that people might be able to create or do, just like in compositing, right, can be really interesting creatively. And I think that's really important. I mean, we just haven't really seen, I mean, everyone's trying to like render things that are real and consistent, but there's also like, somebody's going to create really interesting art with like latent space. But they're not already. I mean, there's already this kind of intent, but we're still early, and I think there's a lot of creative potential here.
Yeah, I think at its core, like these models are actually like rendering engines.
Yeah,
that's what they are. It's like
Yeah.
I think like we maybe we didn't do like good service to it like in the beginning of it when we look talking about these models. It's like text to video or image to video.
Yeah, people have that misimpression of like it's a prompt to something. No, it's just like when you have enough data going into it, you might as well be feeding textures, 3D models. I mean, you're if you're not there already in some small weird way, because it is a different approach, you will get there, I would say, this year, and therefore we're going to be looking at least the same kind of controls. And it is an engine; it's a render of sorts, and you probably can blend that with other. As you're saying, you can stack these things together. You can come up with many different things. But more than a render, you can I mean, just like in traditional CG, you have displacement, you have shaders. I'm very proud of the fact that Octane has OSL, SDFs that you can just create anything in, right? And it renders. That's the kind of stuff that I feel is inspiring with generative stuff. Is if you were to do things like that, where there's a formula that's there, and it can be, you can ray trace into it, or you can use it as a deformer. Lots of things are possible, especially if there's like a reasoning step in there. I mean, it's going to be really. I can imagine a lot of creative levers unlocked.
I think it's interesting too, because if you think about like the training data that goes into building a foundational model, like typically you're trying to teach a model to understand the world, physics, light, and in most cases you're exposing it to only real world values. Where I think so, it's kind of almost coming up from the opposite end from what kind of
Octane.
CG rendering, which is like
it's deterministic, so laws of physics and light. Yeah,
which but I think there's a rationale for both, right? And if you want something really naturalistic, then leaning on a a renderer that's been trained exclusively on real practical lighting. But often what we're trying to do in movie magic is do the impossible, right? Like, and so how do you then infer what you do and what you get out of the there's something about the way that subsurface looks in Octane that's just like, wow, that's like the first thing you see. You're like, wow, it looks amazing. That's something that you can't, unless you like literally found the right exact material and lit it a certain way. Like, how could you actually train a model to do that? And so I think using even, CG renderers as ways to, guide and inform how.
And we have light stage. We have 20 years of light stage data, and we paid people to come in and get, like hundreds of people get scanned. So we have this face data, which we use for our face model, and that is one way of just getting, getting that stuff going in there. And I do feel like there's, it is interesting when you're talking about it. I was in my earlier talk. I was saying, a render, even as precise as Octane is, I mean, if you get the materials wrong or whatever, or the lights aren't set up right or whatever, you're not going to get something that looks great. And even then, it's still noise, right? You're still collecting samples. But we've been shipping for 10 years a denoiser, and that was an AI denoiser. We were one of the first. We did this for optics and all the other AI denoisers. And so every single Octane render practically that was rendered offline was using AI to finish the render. And it's like, well, there you go. And now we have Octane in real time. Octane 2027, the beta that's out now, it has no radiance cache. It has it is using, the neural frame interpolation to basically give you real time. And it's obviously not rendering it any faster. But that's the kind of stuff where you're already blending in tensor cores and ray tracing cores together, and it just goes, you're going to change those values as you wish creatively from there, I think.
I think another fun thing about like at least for me, like with this model, is that like they really get hints. They get hints really well. And I mean, like when I say hints, I mean like you can feed it in like with like low fidelity 3D information, or like you can create all kind of like different custom controls. You were talking about lighting.
Yep.
So I think like we can approach it from a traditional kind of way, but if you actually have the data, you can create all kind of like custom controls to control lighting in a completely different way, but still aim for a very specific like type of result. Like an example from a different thing is like we were looking at dialogues, so scenes of like dialogues, and like with these type of things, I'm sure you've seen it. Like it's always a bit of a struggle to get the right person to talk at the right time, and for the character to actually be interacting with each other like naturally. So we basically created like a specific tool just for that basically allow you in a very like simple way. We just took like scenes of dialogues, and we fed it, like we learned the model to understand who talks when. And we just like trained it that way, and that allows you basically you just use like this adapter over the basic like model, and suddenly you get like dialogue that is super consistent. You don't get like all these like glitches, and again, like I think that's kind of like how I think that like that's what you're gonna see more and more, right? You're gonna because I think now we're at the time where maybe there has been like a shift of like more and more professionals adopting these type of tools. And we're gonna run, and when it's gonna go into actual production, we're gonna run into walls, and I think like solving this type of like walls, breaking through them, is we're gonna see like many different types of solutions and custom controls over it.
Yeah, and you have Jim Cameron join the board of stability. My understanding is because the Avatar wants to make it cheaper, if possible, with some of this technology. I mean, that's the, and of course, I think it's known that like, well, these movies cost a fortune. They're all performance capture, really, and I do feel like there's a lot. I mean, the fact that like our face stuff, we used to, Clay Sparks, who's running our face for 20 years. I mean, we used to put the dots on the people's faces, markerless now, and it's better than ever. I do think that, and that's machine learning, right? I mean, the fact that like you can track a face without having to put any markers on it is a revolutionary thing. That couldn't imagine that really being practical 10 years ago, much less in real time. So there's a lot of just in terms of the friction in traditional pipelines. I think there's so much that could be solved there. I do want to touch on real time. So Richard Karras was here earlier, and he was talking about Vera Rubin. It's a high-end card, of course, and it's not immediately available, but I think they were running LTX in real time on that as well, and they were doing that with Runway, and I think that's exciting because truly, real time is one of those big things. I mean, Octane in the viewport is real time. I mean, even if it was noisy, you need that feedback to really work at the speed that I think people want to. Like when you're filming something in camera, same sort of thing. So how are you guys looking at the real-time space beyond what you guys are already doing, or the community that's trying to adopt it? Are you looking at the at even things sort of more exotic than Vera Rubin? Like there are LPUs, right? Even though I guess Grok is not part of NVIDIA, there's just interesting ways out there that I've sort of that I'm looking at that might allow us to get there, whether it's distillation or quantizing the models, or just specialized hardware. That I think Grok is viable. For and not Grok Elon's thing, but Grok the LPU for generative video. And certainly speed is something that you guys close to real time. So yeah, real time. How do you guys look at it? What's your like? How is that prioritized along with everything else you guys are doing overall for the model?
Yeah, so first of all, like we hear a lot about it. So I think like many people are very interested in this for
Yeah.
different type of like businesses and purposes. I think like when we think about like speed of generation and these type of things, I think there are twofold. One is like for a creative process. So we think about it like a multi-scale rendering. All right, like you should be able essentially to work in like different levels of resolution.
Yeah.
From the really fast, like low latency, we get a result and being able to iterate really fast, but all the way till it gets like to the best quality possible, right? So and like you need like to be able to move seamlessly between these different like scales. This is like how the LTX models are built. We're working now in a much bigger model, and like that, but they should all still gonna work together, so allowing you really to move seamlessly and smoothly between them. And the other way we're thinking about it is really for like different types of purposes of like real time, when you actually want to have this type of like a streamlined experience.
Yep.
And as I mentioned before, like you were saying also now, we already see like different like research labs around the world working on that.
Yep.
So that's very relevant for them, and it's obviously something that we are also like heavily investing in together with NVIDIA and others. Yeah.
Which is great. I think that it's funny because if you want to understand how the model is getting something right or wrong, there's nothing better. Like I guess my understanding with Genie, right, Genie 3, is it is VO, and VO of course is like, well, if you feed it something, is it going to get this thing right or wrong? I was showing, we're building all of the Star Trek sets, and we've been doing this for years, and it's like they're super precise, they're super high quality. The whole team is designing it, and I fed the first round to Genie to see how well it could get because we have all the 3D models, right? And it was pretty good. I mean, it obviously understands how to get depth and move around, and then you turn around and it's like a completely different ship, and it's 3 seconds into it. So what is interesting is I can almost see what VO is probably doing if I were to really push the model around things and how it forgets or does it by looking at what it does in the world model. And I kind of think that even as you're thinking of blocking a shot out, if it's completely neural, or you're depending on this to be a neural render and you're feeding it into something, I mean, understanding what the model is actually thinking or doing or having that introspection live and in real time, I think is pretty powerful. And if you're doing anything dynamic, I mean, I'm not even talking about games, it's just setting up your shot dynamically, changing lighting, things that we take for granted in CG. I think those are critical. I mean, without that, we're still like we're working with one hand tied behind our back relative to the more, the immediate feedback you get in CG. But to your point, the low res stuff in Octane, if you use Octane, right, it's like you have the low res sampling that we used to have to give you that preview quickly, and it would res up. So I think generative video can be. I mean, it certainly can adopt the same approach. And be
I think
very
it'll
useful.
follow the same pattern as virtual production and moving from blue screen to wanting and everyone moved into that, and for
Yeah.
better or for worse. But I think ultimately the result was worse. But when you're getting onto the volumes, but the idea that even directors wanting to have or filmmakers wanting to have the immediacy of seeing an environment
I think it helps the
on
actors,
set,
and
yeah,
everyone like, okay, I'm in this thing. It's not a green screen like on Phantom Menace where everyone was like,
yeah.
yeah.
And even when you're doing, motion capture and kind of those virtual, kind of non-LED virtual productions, and I think that seems to be it's going to be hard to walk back into a world where we're back into like long offline, kind of render methodologies. So I think there's an incredible demand certainly to be able to like even to see proxy versions of what you're doing, and navigate, real-time latent spaces. But I could still see a world where again you get those multiple renders or multiple stacks of renderers where you have your real-time renderer and then it gets shipped to offline to
As we do in the traditional CG space. I mean, you've got whatever Vulkan OpenGL on your viewport, and then you've got the Although we're seeing, I mean, I think even though we're of course now living in a world where all the generative stuff is affecting so much, it is a nice thing to have. Octane basically running noise-free in real time on a 5090. And I only use Octane in that way. I mean, I use it mostly in standalone, but I can't stand like looking at an OpenGL thing and not having it be close to the final thing. I mean, it's just how it's one of the reasons why I love our own product and tool, and I think we need that for these kinds of workflows. But it feels like it's doable. I looked at the very first early things of stream diffusion, right, which was still very messy, and I was like, this could work. This could be really, for a whole scene, right? I mean, it feels like it can get better. And then our own stuff with faces was, again, very tailored. But it was, I mean, if we weren't for real time, actors wouldn't be able to see what they're doing. Directors wouldn't be able to tell them what to do. So for us, it's like we're just putting makeup on the actor, and that also makes it really, it's a very different type of process than just generating stuff whole cloth. And real time is a key part of that.
Yeah, it's gonna be, I think, really interesting to see how like the real world and like, right, because I don't think actors are not going anywhere. No one wants them to go anywhere. It's gonna be interesting to see how like the two things come together, right? How like suddenly like the production, like you mentioned with virtual, right, productions, like how does it actually look like in this new world that is building? And I think like there are gonna be a lot of like really exciting things ahead.
Yeah. Yeah, it is exciting, and I've just seen some really startling results in the last couple of months, and I feel like we're just we're still early in this year, so amazing work, guys, honestly. Well, what's next? I mean, where do you guys see yourselves, like, the end of this year? I mean, I guess at this point, it is sort of this 90-day thing. Everyone's is working on these things, is telling me that it's about 3 months before you fall into the event horizon, but where, what is the next 3 months for you guys like? What do you have lined up for beyond LTX 2.3?
Yeah, so like I was mentioning earlier, we were building like we're planning a much bigger model that is coming. We really try to what we're aspiring to do is really get like the entire range. So you should be able to create your own setup again because it's like completely open source, from being as efficient as possible, going through the way like real time streaming, all of that things, and like be really like that's like low resolution all the way until like highest quality, final pixel, professional production, over like model, and like the ability to kind of like move seamlessly between on that range.
Yeah.
I think this is like the big things that we're working on, and alongside that is kind of like continue to enrich the type of like controls and capabilities that are built around the model.
Yep.
Yeah, and making sure that like it really is usable and fit for like professionals.
Amazing, awesome. Well, I mean, I'm very, very pleased that you were able to make it here and join us for RenderCon and share, the great work you're doing. It is a very interesting, time and place for artists, for software vendors, technology companies, people that are in this space, and I feel like what you guys are doing, especially putting out something that is at this point is getting a great community around it and is likely to get even stronger. I think that's fantastic, and I think that's what the industry needs. And I think you guys are serving a really important purpose and doing great work. So, thank you for that.
Thank you for having us.
All right. Well, I think we're going to take a short break and enjoy the show, guys. Did you guys just arrive here this afternoon?
Yesterday night, last night.
Oh, okay. Well. Yeah, you should definitely check out all the different pieces at the event. It's pretty great. All right.
Yes, and thank you for coming.
Thank you, guys.
Thank you so much.
Thank you so much.